Okay, so today we are going to talk about bearings and courses. So if you're ever interested in learning how to navigate ships or airplanes, it's a good day to understand. So we're going to be on page 4. And so when ships or planes navigate, they need a simple way of explaining what direction they're traveling. So it's not like in a vehicle where you can just like turn right on whatever street. They have to use angles to be able to know they're going in the right direction. So one way is called a bearing, and a bearing will be in the form, you'll either have north or south, and then some kind of angle, an acute angle, and then east or west. And a bearing is always drawn from the north or south, and then you rotate that angle toward the east or the west. And usually ships use bearings to navigate. And then for airplanes, they use headings or courses. And a heading or course is clockwise from the north, or I always think of it like an actual clock, like clockwise from 12 o'clock is what a heading or a course is. And airplanes usually use this because they're getting information from a radio, and if it's garbled, and they'll have to like know the difference between someone saying north or south or east or west, and so it's just easier because there's less information to give. It's just a straight angle. Okay, so we have some angles drawn, and what we're going to do is write what the bearing would be and what the course would be. So the way direction works, and you guys probably know this, is northeast, south, west. All right, and then because this angle is pointing, northeast, you would start off with north, and then whatever the rotation is from the north is the angle you're going to use. So in this case, it's going to be 60 degrees. And then which direction did that angle point? Rotate toward, the east or the west? East. So it's north, 60 degrees east. So the angle is always what you've rotated from the north or from the south. Okay, and then of course is going to be from 12 o'clock, clockwise from 12 o'clock. So clockwise from 12 o'clock is just going to be 60 degrees in this case. Okay, let's look at the next one. All right, so if we're thinking about northeast, southwest, this rotation has come from the south because it's closer to south than it is to the north. And then you're going to rotate a certain angle. So that's 70, yeah. So south, 70 degrees toward the east. So south, 70 degrees east. All right. And then for the heading or for the course, remember it's clockwise from the north or clockwise from 12 o'clock. Yes. So we know that from here to here is 90 degrees. And then we have 20 more degrees added to that. So it's going to be 110 degrees. So of course, we'll just have an angle. Okay. And then for the next one, for our bearing, we would use north or south. South. And then we're going to rotate 35 degrees from the south. So our angle is 35 degrees. And it's rotated toward which direction? The west. Great. Okay. And then the course is going to be from 12 o'clock. What do y'all think? How are we going to get that? Yes. So we know that from here to here is 180. And then we add 35 more to that. And that's going to be 215 degrees. All right, you guys try this last one on your own. Figure out the bearing, please, and the course. So your bearing would be north 72 degrees west. What do you guys need to do to get the course? Good. So you would take a whole rotation, but then subtract away what we know, which is 72 degrees, is going to give you what you want. So that's 288 degrees. So these problems can get kind of challenging. So it's not like it's a set thing you do every time. So sometimes you use 270, sometimes you use 180, sometimes you use 90. There's lots of different ways you can get, lots of different things you can do to get what you want. So in the end, what we're wanting when we're doing these problems is an angle inside your triangle. And so do whatever you have to do to get that. All right, so let's look at example 11. A Jeep leaves its present location and travels along a bearing of north 62 degrees west for 29 miles. How far north and west of its original position is it? All right, so in a lot of these, you're going to want to draw a little coordinate plane. Right, and we know this is pointing toward the northwest, so I would just draw an angle toward the northwest. Okay, and so from the north, you're going to rotate 62 degrees toward the west. So that means that this angle here, when that touches north, is 62 degrees. Now, I know in the last packet I've preached and preached and preached that you always draw your triangle to the x-axis. Always, always, always. And you needed to on that packet. On this one, it doesn't really matter. If I was doing this problem, I would just make my right triangle include 62 degrees. What I would do. It doesn't really matter today. And so I know that the Jeep traveled 29 miles along this hypotenuse. So I would make that 29 miles. And there's two things we're finding. We're finding how far north, which would be this vertical distance, and how far west this Jeep's traveled, which would be the horizontal distance. Okay, so let's start with north. So looking at what we know this angle, we know the hypotenuse, and what we want to find north, which trig ratio would you guys use? Cosine, because that's north is adjacent to 62 degrees. So you would say that the cosine of 62 degrees is equal to n over 29, the adjacent over the hypotenuse. And the variable is of pi, you're going to multiply. And then whatever that would give you, your calculator, that's how many miles north the Jeep is from its original position. Right? And then the other thing we want to know is how many miles west the Jeep is from its original position. So then we're going to look at the two things we know, the angle and the side we know, and we want to find west, which trig ratio? Sine. So the sine of 62 degrees is equal to the opposite over the hypotenuse, and then the variables of pi you're going to multiply. Any questions? Okay, let's look at the next one. So for example 12, a ship leaves a port traveling 15 knots. Do you guys know what a knot is? Right. It's a nautical mile per hour. So someone told me last class and I was wrong, but we're gonna pretend like I'm right if I am wrong because there's no other way to do this problem if we don't think about this as 15 nautical miles per hour. So maybe a nautical mile is different than a regular mile. I don't know. But that is a speed. So 15 miles per hour in the water for 5 hours in a direction of 250 degrees from the port. How far south and west is the ship from the port? So they gave us a hint that is southwest. So I would draw a little coordinate plane, draw at an angle that points toward the southwest. So what I know from my direction is that this angle is 250 degrees. I can't make a triangle out of that angle. So I can do one of two things, and they're both going to give you the right answer. They're just going to look different. I can either figure out this guy right here, or I can figure out this one, and I can make a triangle out of it. Let me tell you which way is easier, just to do it in your head. What is the angle, this angle? 270. What would I do to 270 to find that one? Subtract 250, and what's that going to be? 20. That's what I would do, because you can do that in your head really fast. The other thing you could have done, that would still be 100% right, if you wanted to figure out this one, you would do 250 minus 180, and then you would just draw your triangle this way. Like I said, it would look different, completely different, but it would still be 100% right. So on your answer key, again, I gave multiple answers, just depending on what you did, you can still check to see if you're right. And I'll do the same thing on when I grade your quiz. Obviously, if you did it right, you'll get credit. Okay, so I want to find how far south and west the ship is from the port. What are we gonna put for that hypotenuse? Kind of put 15 knots or something? Do we normally put speed on our triangles? No, we're gonna put distance. So good old distance equals rate times time formula from like 7th grade science or something. We're gonna use that. So distance is equal to 15 miles per hour times 5 hours is 75 miles that the ship has traveled in this direction. All right, so we're gonna do almost identical what we did on the last problem, except we're doing south and west instead of north and west. Right, so to find south, when this is our angle, this is south, this is what we know, that's going to be the opposite and the hypotenuse, so that's going to be the sine of 20 degrees is equal to the opposite over the hypotenuse. So that would be 75 times the sine of 20 degrees miles south. Right. And then for the west, here's my angle. This is W, and hypotenuse is still what we know, so that's going to be the cosine of 20 degrees is equal to W over 75. And so W is going to be 75 times the cosine of 20 degrees miles west. And I really like these hiking problems because sometimes, like reality, you're hiking somewhere where there's not cell phone service or where you're like GPS service, and you actually might have to know this one day. But if you go hiking with a compass, make sure you also have like a scientific calculator or a graphing calculator, something that will do sine, cosine, or tangent if you want to find your way back in a straight direction. So anyway, example 13, a couple is hiking with a compass. They leave their camp and travel due south for 1.5 miles. Then they travel due east for 5 miles. How far from camp are they? And what heading must they travel to get back to camp? So they want to get straight back to camp, not in an extra long direction. So let's figure out where they are. So camp is here. They travel south first for 1.5 miles, and then east for 5 miles. And then they want to go straight back to camp. So let's find that first, because that's not, we're going to have to use sine cosine tangent to find that. What are we going to use? Pythagorean theorem. Are we going to add or are we going to subtract? We're going to add. So if you're looking for that hypotenuse, you add. And your little blue calculators can do this kind of math for you. You can square that, add them together, and you're going to get 27.25. And then in the square root, you get approximately 5.22 miles from camp. All right, so if they go straight back, it's going to save them. If they go back the way they came, it's 6.5 miles. Okay, so the second part of this is they're using a compass. And compass is, if you've ever looked at a compass, is the angle from the north. So it works the same as a heading or a course. We want to, this is where they are. We want to figure out this angle. That's the angle they would take on their compass. But we can't do that directly. What we can find directly using trigonometry is this angle. You want to get a pretty accurate measurement. So you wouldn't use this 5.22 that we rounded to find. You would use the ones that we know exactly. So what trig ratio would you use to find theta? Opposite and then adjacent, right? So we use a tangent, good. So the tangent of theta is equal to the opposite over the adjacent. So if we know what the tangent is, we want to find the angle that has that, what do we do? What type of tangent? Inverse tangent or arc tangent, very good. So this is the angle inside the triangle. That's not the angle they would take on their compass, because that would take, this is an acute angle, it would take them in the wrong direction. We don't want to do that. So we know this angle, but we want to know this one. What would you do to it? You would add 270 to it. So from here to here is 270 plus a little bit more that we found. That's going to be the heading. That's why you need to make sure you take your calculator with you when you go hiking. So the heading back is going to be 270 degrees plus whatever we get for the inverse tangent of 1.5 over 5. Any questions? Okay, so your assignment today is to just completely finish the packet. So there's 4 problems that involve headings and bearings on page 8. And then the whole review for the quiz is on page 9. And it's going to be a really short quiz. It only has 5 questions on it, just like this review does. I'll have some time to answer some questions before the quiz. I probably won't do the whole review, so hopefully you'll be good. You might have just a question or two right before the quiz.